Okay, welcome back. Happy Friday. We have just finished test number 1. We have 3 tests during the semester plus the final exam. So that was our first one. I've given it back to you. If you have individual questions about your tests, see me individually, for example, right before or after class, any day, including today. Generally, the results on the tests were good. I've written some data up here on the whiteboard. Median grade was 86.5. Remember, median is middle. So half of you scored higher than 86.5 and half of you scored lower than 86.5. You are not in a competition with anybody else. There is no curve. It doesn't matter to you how anybody else did on this exam, but I give that to you for informational purposes, just so you can sort of gauge the general difficulty of this particular test this semester. High grade achieved by one person was a perfect score of 100. Okay, so I want to say one more thing about the test, a couple things more about the test actually. So I wanted to take a look at this question, which was 6B. 6B. So up above, I had asked you to find the formula for the derivative using the limit definition. And so we go through the whole big calculation with all of the algebra and an h, and h's cancel. Ultimately, we get what we expect to get, which is 3 minus 4x. So then it said, find the equation of the tangent line here for that same exact function. And so I'm pointing this one out because enough folks sort of went wrong here. I wanted to just make an observation. So first of all, a couple of people did the derivative calculation again, starting from scratch, doing the whole limit h going to 0, but just plugging in the specific number -2. That was not my intention. You calculated up above what the derivative of this is in general. It's 3 minus 4x. So my intention was for you to just plug that -2 right into the derivative that you've already found, 3 minus 4x, and then I think it's -11. So the other thing that I saw is that some people got the derivative of -11. Is that right? -11, and then stopped and just said the answer is -11. Well, -11 is related to the tangent line. What is -11 for that tangent line? It's the slope. And so I really tried to highlight, hey, don't just stop once you found that slope, but continue on, and most folks did the mx plus b thing and found the y-intercept, so that was good. Yeah, so it should be the -2 for the x, and the 11 is just the slope. Okay, other thing I wanted to say before we jump in here on page 11. Okay, again on the test, there was a question there, number 4, which said find the derivative, and it was a quotient rule. You guys remember that one, right? Okay, and it said do not simplify. And some of you had a hard time following my directions when I say do not simplify, and you spent, I don't know how much time. I didn't bother looking at it, but some of you spent a lot of time simplifying in a problem where I was expecting you to do the quotient rule and stop. So the quotient rule was just parentheses times parentheses minus parentheses times parentheses over parentheses squared. Stop. A lot of you did a bunch of algebra there. You felt like obligated, compelled to distribute and combine like terms and factor out, and you didn't have to do any of that, right? I'll tell you when you need to do algebra. It wasn't that moment. Okay, next observation. All right, so this, so during the test, so the test is 2 hours long, and a bunch of folks ended up going to the bathroom during the test, and I suppose that's okay. I don't have like a strict don't leave the classroom kind of policy, but it was just like an extraordinary number of people left this classroom during that test, and there were times where I had to say, hey, you need to stay and wait for the other person to come back in so that I know you're not like exchanging answers in the hallway. So just putting it out there, I'm not like making a new policy here, but if you're able to use the facilities like right before the test, that might be a little bit less disruptive to you and also to the people around you, because there was just a lot of walking around, and I think that might be distracting to some folks while they take a test. Also, I probably should have said this before the test, but I didn't think of it. So I'm happy during the test to answer any clarification questions. So if there is a question that you don't understand, like what the wording is, or if you're just not clear on exactly what I'm after, I'm happy to like rephrase the question, give you some synonyms. But what I am not happy to answer is, hey, can you help me on this question? No, I cannot help you. I'd love to help you, but this is exactly the only time when I cannot help you. But I feel like I'm a nice guy, and I feel terribly awkward saying that during the test to somebody. So I'm going to ask you not to put me in that position. Clarification questions only during the test, right? Everything else is on you to figure things out. Okay, next thing is about your grading choice. So we haven't really talked about this, but on the syllabus, there are two different options that you have for how you want me to calculate your final grade at the end of this semester. They are called homework counts and homework doesn't count. And if you look at the bottom row, you see that on the one hand, homework can be 5% of your overall course grade, or homework can be 0% of your overall course grade. If you choose the 0, that 5% goes into the tests. So you can see the only other change here is the test could be 46% or 51%. So you need to make this decision and tell me next class. Decide for me over the weekend and then tell me on our next class. So I will ask you next class. Each of you I will ask, does homework count or homework not count? I'm assuming most of you are going to want homework to count. It minimizes the impact of a bad test, maximizes the free points that you get for homework. I don't want to say they're free because you have to work to do the homework and it is your time. But it's a way to get 100% of those 5 percentage points if you put in the time to do the homework. But you all know what your study habits are by this point in the semester, and can you commit to regularly doing the homework? And so I have these two options for you, okay? So I will ask you to give me a decision next class. Okay, so I think that's good there. All right, so taking a look at the calendar, I handed out 2 projects at the test. You didn't have to look at them between now and then, but I just figured in case folks wanted to, I'd give them to you. So 2 new projects, just like before, and they are due 1 class apart. Looks like end of October. Steel drum and pipeline. Just like before, there is a recommended calendar on the first page for each of the 2 projects. These projects have more questions in them than the other ones did, and the first 2 did. I don't think that makes them longer. A lot of the questions are really short questions, but there are more of them. I encouraged you before to follow the recommended timeline, and I'm going to encourage you again to follow the recommended timeline. Another reason it's a good idea to follow this timeline is that the grades on the projects for the people that handed them in on time were really good. The grades on the projects for people that handed them in late were significantly lower. And I'm not talking about because of any lateness penalty, I'm not even counting that. But I think that the folks that were working on time had other people in the class they could check in with, and the people that did them late, I think, were largely working individually. And just the fact that you had other people that could help you out and push you when you were stuck or catch little errors, I think really helped the folks who were on time. So good idea to stay on target. All right, I think that is good. Okay, so let's jump in. So today we're going to talk about, we're going to review composition of functions. That is like a pre-calculus or 107 college algebra type topic. And then we'll talk about the chain rule. The chain rule is the most important derivative rule of the entire semester. So important that we're going to spend 2 days on it. So we'll do this again next class. I will also point out our next class is not until Wednesday. This coming Monday, there are no day classes for Columbus Day. But if you have a Monday night class, you go to your night class. Night classes don't care about Columbus, all right? Go to night class Monday, but we don't have class until Wednesday. All right, so I think we're good. Let's jump in here on page 7. Today we learn a new derivative rule called the chain rule. The chain rule is used to take derivatives of composite functions, so we'll also briefly review composition of functions. All right, so let's jump down here to the demo. We present a new derivative rule that allows us to take the derivative of more complicated functions called the chain rule. Basically, we are going to apply the normal derivative rule and then multiply by the derivative of the stuff. You're going to hear me say this phrase many times over the course of the semester. This is the brand new thing for today, is you just do the normal derivative rule, but then multiply by the derivative of the stuff. So here we go. We don't have a good justification, at least I'm not going to present any justification for why the chain rule works, so we're going to take it on faith. I'm not at any point going to present a justification for why it works, but it is still true. So let's use it here in number 5. Okay, first one. Easy problem from before. Y prime equals, what's the derivative of x to the 23? 23x to the 22. That's just our ordinary power rule. And now let's take a look at B. Y equals quantity x squared minus x plus 1 to the 23rd. B looks an awful lot to me like A. It's just instead of x, there's something more complicated in those parentheses. But we're going to pretend that it's the same exact derivative rule as it was when it was just x. So y equals. We brought the 23 down, we're still bringing the 23 down. Over here in blue, we copied the x. Well, we're going to copy what's over there in parentheses, just like before. What's the new power? 22. Thank you. All right, so that is our normal derivative rule, and it you know, like that, we've just applied the same power rule, but to something more complicated. So the fact is, this answer is part of the right answer. It's just incomplete. So the new thing is that you do the normal derivative rule, which we've done, but then you multiply by the derivative of the stuff. We didn't just have x before. We had x squared minus x plus 1. We need to multiply by the derivative of that thing and put it right here. Just the stuff in the parentheses. What is the derivative of there? 2x minus 1. It needs to be in its own set of parentheses, and that is the answer. Do your normal derivative rule, and then multiply by the derivative of the stuff. And just so that I can convince you that we haven't been cheating before, because we've never been multiplying by the derivative of the stuff before. But what's the stuff in this problem? Is x. And so if I wanted to use this brand new rule and I say multiply by the derivative of the stuff, I'd multiply by 1. Derivative of x is 1. And so like we have been doing this, we just never wrote it because it's silly to write times 1 at the end of every one of these problems. But this rule doesn't contradict anything that we've done before. All right, let's take a look at part C. There's not near enough space up here, so let's bring this down here. Okay, at the moment, this is not in like a power rule form. I really want it to be some things to a power, so we need to change that. So y equals, copy everything here. And then the cube root we change to what power? 1/3. All right, so Hunter called me out and took great pride in it for putting a y before instead of a y prime. Should this be y prime? This is still y, right? Okay. So the next line is the one that's going to say y prime. Okay, so we do our normal rule. The power comes down, you copy the stuff, you subtract 1 from the power. 1/3, everything in the parentheses. And then subtract 1 carefully. We get negative 2/3, all good there. And if this had just been x to the 1/3, we'd be done. But if it's anything more complicated than x, you just have to multiply by the derivative of the stuff. I will highlight it in green this time. Here's the stuff. Here's where its derivative goes. So 4x cubed becomes 12x squared. 5e squared, does that become 10e? Right, 2 comes down. That's right. Is that the derivative of the 5e squared? Ryan? Ryan says e is just a number. So 5e squared is just a number. So what's the derivative? 0. Okay, so we get rid of that guy. And then plus 10x, that becomes a plus 10. Minus 1, that's another 0. So why is the e is just a number. E squared is also just a number. Oh, it's all just a number. So like it looks like a power ruleable thing, but it's not, it's just a number. Okay, that's it. That's the derivative. Okay, part D. All right, I see a bunch of stuff to the 10th and then a bunch of stuff, and I can't really read that. Is that a pi? Yeah, okay. All right, so then a bunch of stuff to the pi. But this is not a chain rule problem first and foremost. What derivative rule is this primarily? This is a product rule. The product rule is going to have some complicated chain rule derivatives inside, but this is a product, and so we have to first and foremost apply the product rule. So here it goes. Y prime equals. All right, so in English, first times derivative of the second. So first, we're going to copy. And the first is all of that, including the 10th power, and then times the derivative of the second. So here's where the brand new chain rule comes in. So the derivative of the second, I see some stuff to the pi. Well, this is just an ordinary new power rule. So what comes down? Pi. You copy all of the stuff in the parentheses. It's really common to take a derivative of that and put it in the parentheses. That's not right. You copy that stuff one time every time. What's the new power? You could put it as a decimal, but I'd rather you leave it exact, so leave pi up there. But then the chain rule says times the derivative of the stuff. I'll highlight in yellow. There is the stuff in question. Here is where its derivative goes. So what's the derivative? 16x minus 18x to the 5th. Good. That one's done. Yeah, E is around 2.7. It's just a number. Yeah. Okay. Is easy to get lost in the middle of the bigger rule when you're doing smaller rules, but this was a product rule, and all we've done so far is half of it. We did the first times the derivative of the second, but then we continue plus the second times the derivative of the first. Copy that second thing in its entirety. Times the derivative of the first. What comes down? 10 comes down. Copy all the stuff in the parentheses. What's the new power? 9. But then the chain rule says you're not done. You need to multiply by the derivative of the stuff. That stuff is now in green. Its derivative goes right there. What's the derivative? Good. If it were a quotient rule, it would be over some things, right? Product rule has no denominator. Okay, so that's product rule. Inside of the product rule were 2 chain rules. And again, if I give you a test question and I say, don't simplify, you stop. That said, I will tell you there are going to be things like this where we will have to simplify, and I'll say, like, you're never going to have to do some massive distributing, so that's not what we're about. But every time you do one of these kinds of product rules, there's something you can factor out. There's a greatest common factor you can take out. There's the plus sign. And so in the front of that plus sign, I see 5x squared plus 2x minus 3 to the 10th. And after the plus sign, I see 5x to the 7 plus 2x minus 3 to the 9. And I can take out how many of those from both? I can take 9 of them out, right? And that's going to make both of them, like one of them will just vanish entirely because it'll be in the front. And then the other one will just be to the first power, which is a lot more friendly than it currently is. Same with the other one. 8x squared minus 3x to the 6th to the pi minus 1, 8x squared minus 3x to the 6th to the pi. Don't get thrown off. How many can I take out of both? It's the pi minus 1. It's a smaller one, right? You could take 9 of them out because that was smaller. You can take pi minus 1 out. That one will disappear entirely into the front. And this one will just become 1 to the first power. Okay. Yeah, the 10 and the pi aren't going anywhere. It's just the stuff in the parentheses can get factored out. Yeah. Okay, so that's good. Let's take a look at our last one. There's E. No idea where I intended us to do this work. I'm gonna copy this one down here. I think there's enough space down here, but can somebody read me that square root? Thank you. Okay. So let's try our derivative here. You look at that, it might feel like quotient rule, and that's part of the answer, but this is not a quotient first and foremost. This is something inside of a radical. And if I see a radical, I'm immediately changing it to a power. So this is 3x minus 4 over 2x cubed plus 5 to the 1/2. And now I can see it as some stuff to the 1/2 power. And this is a power rule, chain rule combination. So let's take our derivative. y prime equals, what comes down? 1/2. Copy all of that stuff one time. Yeah, that's right. So what's the new power? -1/2, right? Subtract 1 from the power. And then times the derivative of the stuff. I will highlight in green. There is the stuff. There is where its derivative goes. Notice there's a lot of green, because what derivative rule do we need to apply here? That is a quotient rule, right? Taking the derivative of just the thing in green, that's where the quotient rule is. But it wasn't a quotient rule to start. It was a power rule to start. And inside of the power rule pops out a quotient rule. Okay, so I think I said this before when we first did the quotient rule, but they can get complicated and it's easy to forget that there's division. So I do that part first. What's the power? Squared, right? Bottom squared. It's part of our quotient rule. I always write that first. Okay, so quotient rule says bottom times derivative of the top. So copy the bottom times the derivative of the top, which is 3. That's good. Minus, copy the top, times the derivative of the bottom, 6x squared. Questions on that one?
You don't care about distributing.
Sometimes I'll care about distributing, and I will tell you, but the calculus in this problem is done. Yeah. I will point out a couple of folks went wrong here trying to simplify when on that quotient rule example. This 2x cubed plus 5 on the top has a partner on the bottom, right? So it's very tempting to say, okay, I got 2 of them on the bottom, so I'll just have 1 of them on the bottom and then get rid of the 1 on the top. What's wrong with that? Yeah, the thing on the top is not cancelable. The thing on the top has subtraction floating nearby, that big subtraction sign in the middle. So the thing on the top just isn't ready to cancel. The one on the bottom, it's ready to cancel, but the one on the top isn't. And the like dastardly thing about the quotient rule is that it will always give you this opportunity, right? Like think about it, it's bottom times derivative of the top, right? So first thing you're doing is putting the bottom and then the bottom squared. And so there's always an opportunity to do this, and it never works, but it's there. Okay, number 6, real common mistake in using the chain rule. I think we did this one, was our part B up above. So we know we're supposed to bring the 23 down, and then the derivative of this stuff in here is 2x minus 1. Everybody see it? So I'll highlight in blue, there's the stuff, and there's its derivative. Subtract 1 from the power, and then times the derivative of, what's the derivative of this 2x minus 1? It's 2. So that's what the student did. It isn't right. What's the problem? Yeah, we need to copy the original stuff one time, and this student did not do that. This student jumped the gun on taking the derivative of the stuff. The 23 is good. Yeah, like the 23 is good and the 22 is good, but the thing in the parentheses is not good. It needs to get copied one time before you take its derivative. When I took AP Calculus as a high school student, I had a classmate who just couldn't figure out like when to stop with this chain rule. He would say, okay, x squared minus x plus 1, that becomes a 2x minus 1, and the derivative of that is a 2, and the derivative of that is a 0, and every problem he did ended with a 0 at the end because he just kept taking derivatives. So how many times did we do the derivative of the stuff on all of these problems here? Once. Blue, derivative, blue, once. It's just one derivative. You don't just keep going until there's no more to do. Just one time. Okay, I think that is the demo. On the next page, I will point out, there you go. Don't bother simplifying your answers. Just write the derivatives.